Welcome, everyone, to today's Explainer. We are taking a seriously fascinating journey back to the mid-17th century today to dissect a truly brilliant piece of work by Margaret Cavendish. Specifically, we're going to be looking at her 1653 poem, A World Made by Atoms. Now, you might be wondering, what does a poem have to do with atomic physics? Well, as you'll see, Cavendish used poetry not just for artistic expression, but as a deeply sophisticated scientific tool to explore the very building blocks of the universe. Okay, let's dive into this. The poem opens with a really bold statement. Small atoms of themselves a world may make, as being subtle and of every shape. With just these few words, Cavendish immediately plunges us into 17th century atomic theory. She's talking about the microscopic, invisible world and suggesting that these tiny, remarkably varied shapes are fully capable of constructing the entire universe around us. I mean, it is a materialist manifesto right out of the gate.
But to really appreciate what Cavendish is doing here, we have to ask ourselves, how do you debate science when you're literally locked out of the room? This is the core historical tension we need to understand. Cavendish possessed a brilliantly curious mind, but as a woman in the 1600s, she was strictly barred from participating in formal academic institutions. She couldn't just walk into a university or a scientific society and present a paper, so she had to find another way in.
Section 1. A Changing Scientific World. The 17th century context. So, the mid-1600s was an incredibly dynamic yet highly divided era. Early modern natural philosophy was rapidly evolving and actively challenging ancient classical ideas. On one side, you have the newly forming scientific boys' club. Think the Royal Society, men like Robert Boyle, who relied heavily on mathematical rigor and formal academic settings. On the other side, we have Margaret Cavendish. Excluded from those institutions, she turns to poetic metaphor and plain diction to bypass the traditional academic gatekeepers entirely. She wasn't ignoring the science, she was translating it into a language she was actually allowed to use. And the science she was tackling was highly advanced. It was called corpuscularianism. This was a cutting-edge, early modern mechanical philosophy, asserting that all physical matter is composed of minute, indivisible particles, or corpuscles. By writing explicitly about atoms, Cavendish was actively engaging with this exact theory. It proved she wasn't just writing pretty verses. She was deeply involved in the complex mechanical philosophies of her day. Section 2. Poetry as Scientific Tool. The medium is the message. For Cavendish, the medium truly was the message. The poetic format itself wasn't just a container for her ideas, it was a vital piece of her scientific technology. She structured her poem using iambic pentameter and closed couplets, which creates a highly didactic or instructional framework. Her choice of rhythmic verse and plain diction was actually totally typical of philosophical vernacular exposition at the time. She was specifically designing her scientific writing for non-academic readers. If the men in the universities wouldn't listen to her, fine. She would take her theories directly to the public through a format they recognized and enjoyed. Now, her poetry wasn't always flawless by strict literary standards. She prioritized conceptual clarity over formal polish. Scholars often note that her meter was sometimes irregular, but here's the thing. This wasn't a flaw or a lack of skill. It was a deliberate choice. For Cavendish, her versification ultimately served her scientific argument. She would rather a line be a little clunky if it meant the physics she was explaining remained accurate and understandable. She was doing science first and poetry second. Section 3. The Architecture of Atoms. Metaphors of Construction. Let's zoom in on the specific mechanics of the poem now and decode exactly how Cavendish envisioned these tiny, invisible atoms actually interacting to build the world around us. Listen to this stanza. For when we build a house of brick and stone, we lay them even, every one by one. And when we find a gap that's big or small, we seek out stones to fit that place withal. And this brilliantly illustrates her genius. She takes incredibly abstract physics, the interaction of microscopic corpuscles, and explains it using highly accessible domestic artisan labor. Everyone knows how a bricklayer builds a wall. By using this metaphor, she instantly demystifies atomic theory for her reader. We can actually translate her 17th century verse into a very modern mechanism. First, the atoms dance about, representing continuous motion. Second, they find fit places, representing geometric compatibility. Third, they either stick fast or fall away. What's so remarkable here is that she's describing an almost organic coordination. These atoms are self-organizing based on their shapes fitting together. They are building a structured reality from the ground up, entirely without needing a central top-down director to place them there. Section 4. Chance versus predestination. The cosmological stakes. So, if atoms are just bouncing around and self-organizing based on shape, what does that mean for the entire universe? Well, Cavendish wasn't just interested in physics. She actively blurred genres to explore massive philosophical and cosmological questions. We see this tension most clearly in the final, highly ambivalent lines of her poem, and thus by chance may a new world create, or else predestined to work my fate. She ends on a note of deep hesitation. Is the universe just a random accident of dancing atoms, or is there an overarching destiny? She presents both options to us, but absolutely refuses to firmly commit to either. She is playing with a profound tension here. On one side, you have pure chance, where fate is just a speculative byproduct of atomic collisions. On the other side, rigid determinism and assured divine order. By leaving the poem unresolved between these two poles, Cavendish introduces a profound metaphysical uncertainty. And this was actually quite subversive. It was a subtle, yet really sharp critique of her era's overwhelming tendency to confidently assert a strict divine order in nature. She's looking at the mechanics of the atom and essentially saying, you know what, we actually can't be so sure.
Section 5. An alternative epistemic mode. Cavendish's legacy.
So, what is the enduring impact of her unconventional scientific approach? Let's summarize her unique contributions. First, she successfully translated abstract theory into incredibly accessible metaphors, bringing science right out of the ivory tower. Second, she bravely critiqued the assumption of rigid divine order in the cosmos. Third, she uniquely balanced scientific materialism with a healthy dose of metaphysical uncertainty, something that was rare even among her male contemporaries. And finally, she pioneered an alternative epistemic mode. Because she was excluded from the formal institutions, she just carved out her own space. She successfully asserted materialist possibilities on entirely her own terms. Which leaves us with this final, absolutely vital question to ponder. What modern scientific voices are we missing today because they don't fit the traditional mold? Margaret Cavendish proved that brilliant scientific insight doesn't always come in the form of a mathematical treatise from an elite institution. Sometimes it comes in the form of poetry from someone locked outside the building. It really makes you wonder who the modern Margaret Cavendishes are and what alternative modes of knowledge we might be completely overlooking right now. Thank you so much for joining me for this explainer, and as always, keep questioning the world around you.